Good morning. Question 15, as requested. So in question 15, you asked to consider three different functions that represent population growth. So I'm going to have a little bit of analysis here because you always have to start by interpreting. 40 million and increasing. So these 40 million, 45 million, and 80 million all represent starting values. Increasing uniformly suggests that this is increasing linearly. It's increasing by 20 million every 5 years. Now, I'm just going to make the note here, because it says 5 years, I'm going to use fives as my scale. Not 1 year, but 5 years as my scale. So my T will be the number of 5-year increments, but we'll get to that in a minute. This one is increasing by 25% and 10% every year, so they're going to be exponential growth, or a geometric sequence. So technically, this is an arithmetic sequence, whilst these two are geometric sequences. But I'm going to have to use my linear modelling skills and my exponential modelling skills to actually create the graphs and deal with that. But this does come strictly from topic 1 and topic 5 of unit 1. So for A, I can see that this is equal to term 1 plus ND. So you notice here that I'm not using the n minus 1, I'm using the n. If I go back to the context, if n is 1, in fact I'm going to call this term 0. So the first term is term 0, that's at time 0, which is going to be 2020. And then my subsequent terms will be each 5 years, and n will represent the number of 5 years. So my common difference for A and my first term is 40 million plus n times my common difference is 20 million. Increases by 20 million every 5 years, where I let n equal the number of 5-year increments. So that's first. So that's my model A, and I'm going to use A to represent that, although I'm going to swap that. In fact, I'm going to rub A out. I'm going to call this population A, because when I actually draw my graph, my y-axis will be my p-axis for population. So I'll call it PA. And just to simplify it, that's equal to 20n plus 40. Now my second one, which is PB, has a geometric pattern. In this case, it's in the form T0 again, times r to the power of n. Because I'm using T0, I'll use r to the power of n, not n minus 1. And in this case, my T0 is 45 million, and my r is 1.25. So remember, I get that 1.25 is equal to 100%, plus a further 25%, which can be written, of course, as 25 over 100. So I get 1.25 from that, and that's to the power of n. This is now an exponential function, as we talked about in that 13D and E a couple of weeks ago. And then PC, this is equal to 80 times 1.1 to the power of n. And so I'm going to sketch these now. I'll do a rough sketch on here, just to show you how we could quickly draw it together. And I can change my view. I'm lucky I can do this in here to a grid. So we'll do a rough sketch on this grid here. I'm just going to zoom out a little bit. So first I'll just set up a really dodgy y-axis, a really dodgy x-axis there, and there. So this is my population axis, and this is my n, number of 5-year increments. And I can do this really easy. If I just go and change my color, let's say in orange, here's my 40, so this is for my first one, and each 5 years it increases by 20. So along, I'm calling this n equals 1. Should probably do that in black, but you can see here I've kind of represented that as 5 years, just to make things a bit easier. So 1 there, 2, etc. And so this is equal to that, and then my linear function, that's my linear growth function there. The next one, which I'll do in green, starts at 45, and there's a growth of 1.25. So if I just quickly grab a calculator, so you'll see that growth of 1.25 will mean that after one time period, 45 times 1.25, I get 56.25. So after 1, I'm at 56.25, which is here, and then times 1.25. After 2, I'm at 70.35, which is about there, and so on and so forth. So this model looks like this. And it will continue on. Now, because it's exponential, it will eventually surpass that orange one again. And then I'll do my last one in purple. Starts at 80, so maybe a little bit high. I might have to track. I'm going to rub this out so it doesn't blur too much. And I've got 80 times 1.1, so it's 10%, gives me 88, which is here, and then times 1.1 gives me 96.8, which is here. So this one is growing as well. It's growing slower. So my knowledge of exponentials and linear functions is there's a very good chance the purple will remain above that linear function the whole time. It might not. Maybe it'll cross over and then cross back over. The green one, though, has got the fastest exponential growth, so eventually that green population will be the biggest. So what I'm going to do now is just pass back across. I'll just flip my screen up here, so I can memorise these, because it says you can answer the next bits using technology. So let's just practice that use of technology. And to do that, so I'm just having some trouble with my mouse here. My calculator, and I might actually just bring this along here so I can see the models there, and I'll leave it so it's reasonably big. And I'm going to go down the graph, and I've got all this stuff in here. Keep in mind, if you've got previous graphs, I've got a lot of them because I play around with this a bit. You can deselect them. So if you're in the exam and you want to keep one in case you want to check an answer later, just deselect them using F1. And now go to my new graph there. I'm going to start with 20. I do have to use X plus 40, so that's my first model, and that's in black. My second model is going to be 45 times 1.25, and then to the power, which is this button here, of X. That's my second one, and that's in blue. And my third one, which will be in red, is going to be 80 times 1.1 to the power of X there. And I'll just press enter on that. So there's my three functions, blue, black, and red. I'm going to draw that now. And you can see that my scale is not very good. So I'm going to go Shift V window. And I have my X minimum at, keep in mind I only need to go, 1 will represent 5 years. So I'm going to go from -1, but I'm going to go up to say 10 for now and just see what happens. And then my Y minimum, well, again, my population starts, my lowest is 40, but I'll start at 0. And I'm going to go up to about 150 and hopefully that'll bring everything together. So let's have a look at if I draw that. Okay, so you can see that little area here is our area of interest. I could zoom in on it if I want to, but actually if I go back up to the question on here, it says draw a graph. We've done that. Use the technology permitted. Well, we've done that. But we need to determine the year in which the population of A first overtakes the population of B. So if I go back to here, that is when does the black first overtake the blue, which is about here. So I'm actually going to go Shift G solve and find intersection points. I'll select my black graph and I'll select my blue graph. That's the one that's flashing at the moment. And there's my first intersection point. And the answer is at 0.53. Now I'm just going to stick on my graph, so I'm just making a note of that on paper and I'll copy that across at the moment. X equals 0.53569. As that's my X value, which is the number of 5-year blocks. So we'll do that in a minute. And of course, this is at a population of 50.714 million people. Okay, question B, for how many years does country C have the largest population? So country C is this red line, so I need to find some more points of intersection. The first one I'm going to find is, that's just finding those blue ones, so I need to exit that. There we go, and redraw it, and then I can go Shift G solve, and I want to find the intersection points between that black one, and then I just have to toggle to that red one there. And there's my first intersection point. So I've got, it starts, talking about the red one. Oh, actually, how many years does country C have the largest population? It's just from time equals 0 to then. So then is X equals 3.68104. So we'll just record that. And then the last one, the government of country C's plans to alter the immigration policy when their population is halved. In what year will this occur? Oh, I've made a mistake here. So this is, so I'm sorry, you've been watching this video and I've made a mistake. This is classic Manson. Look at this. Decreasing by 10%. My most sincere apologies. That is 0.9, and so this should actually be 80 times 0.9, which is 72, times 0.9, which is 64.8. So let me update this in pink. 72, and then 64.8, which is here, and so it's an exponentially decreasing function like that. So my apologies. Let's go back to here. Let's exit this, and let's change this function to be 0.9. Okay, and I'll draw that again. Okay, you can see we've got a changing value here. So I need to change my answer to B. Luckily they are C, otherwise I might not have recognised it. So it's going to be from where the red line intersects the black line, and the red line is the highest population until then. So I choose the black line, and I'll toggle up to the red line, and the answer is actually at 1.4. So I've lost my calculator there. This is B, 1.4377. Okay, and we'll fix it up in a second. And then, and look at this, that's about 1.43. That's actually great graphing there by me, thanks. Finally, this last one, the government of country C plans to alter their immigration policy when their population is halved. So it'll halve when it gets down from 80 to 40. In what year will this occur? So what I'm going to do is you could solve N and let PC be 40 and solve that. What I'm going to do instead is I'm going to exit here. I'm going to draw an additional graph at y equals 40. This one will be in green. If I draw this graph, you'll see it's down here, and I want to find the intersection point between the red graph and the green graph. That will be when the red graph is 40. So I go Shift G, solve, intersect. I toggle using the arrow key on here until I get that red one, press enter, and then I toggle down to the green one, which I've got there, press enter, and that intersects at x equals 6.5788. Okay, so I'm just going to flick off the calculator now, although I might just take a screenshot of it to add onto here, because I know that some of you will be looking at the OneNote for this. So there's my screenshot. Paste that there. Okay, so our answer for A was when did they first meet? So I'll do some really dodgy working and write the answers on here. So for A, it's at N equals 0.53569, which is, in terms of time, it's 0.53569 times 5 years, which is 2.678. 2.678, which is going to be in 2022, about halfway through the year, at about August. You could do a better calculation on that, but 2022, August, September will be when the green and orange first meet. So that's population of A and population of B. The second one was how long is the pink ahead? And remember, when we're all ignoring that purple, so we're at this point here, and that was at 1.4377. And so again, I multiply that by 5, because remember that N represents the number of 5-year groupings, times 5, 7.18. So it's 7.18 years, which is going to be about 2027, and around about February, if we're going to that level of detail. Although I'll just check, yeah, for how many years. So you don't really need that February, and for how many years, that's actually the correct answer. So we're good there. Determine the year, so I don't really need the month for A either. And then the last one is, remember I drew that graph at 40, which was this one here, and that pink one obviously keeps on going. So at some point over here they met, and that some point was at N equals 6.5788, you can see down here, and that is time equals, we get that 6.5788 times that by 5, so it's 32 years time, 32.894 years time. So in approximately 20, and we're starting 2020, so 2052 very late 2052, so we'll probably say 2053 will be when that immigration policy will change according to the context from question C. Now I would probably do this a little bit neater, do my working a little bit neater, and I would write some sentence answers given the sentence questions here, but hopefully that answers how you go about this question, and you'll have to ignore my little mistake there. Thank you.